finding f of 4 would equal 2 times 4 cubed plus 5 times 4 squared minus 28 times 4 minus 15, or 2 times 64 plus 5 times 16 minus 28 times 4 minus 15. So it would be 128 plus 80 minus 112 minus 15. So that would be 208 minus 127, and there's the 81 that we had when we just filled in the values. The points on the graph give the number of men in the workforce, notice in millions, as a function of function g of the year t for selected years from 1890 to 2009. I'm going to find and interpret g of 1950. So g for the year 1950. And here's our year 1950. Going straight up, we will, that f of g then equals 42.8 from the table. But notice it's in millions. We want to interpret that. What does that mean? It means there were 42.8 million men in the workforce in 1950. If we go straight down, we'll find out that the input was 1990. So in 1990, there were 86.5 million men in the workforce. Same graph again. What can be said about the number of men in the working force from 1890 to 2009? I would say, looks to me like an increase. And one more thing, what is the maximum number of members of the workforce during the version shown? Well, what's the biggest number? The maximum? 73.6 million men in 2009 was the maximum number in the workforce. Modeling. Modeling, for mathematical modeling, is the process of translating real-world information into a mathematical form so it can be applied and interpreted in a real-world setting. This gives you a mathematical model, usually in the form of an equation. So we're taking a real-life situation and we're making it into an equation so we can apply that equation and interpret it, the results in the real-world situation. We have an example for modeling. Public health care expenditures from the period from 1990 to 2012 can be modeled, that means accurately approximated, by this function. E of t equals 738.1 times 1.065 raised to the t power, where f of t is in, E of t is in billions of dollars, and t is the number of years after 1990. So what value of t represents 2005? Well, 2005 is how many years after 1990? It's 15 years after 1990. So that's the answer to this question. We want to find the approximate public health care expenditures for 2005. So what we will do, E, in this case, T was 15, equals 738.1 times 1.065 raised to the 15th power. When you go to put that in your calculator, put in 738.1 times 1.065 raised to the 15th. And you will find out that that equals 1898.275,847. So it looks like approximating 1,898.276 billion dollars would be that approximate answer. Now, use this model to estimate the public health care expenditures in 2020. Well, in that case, T is going to equal 30. So we'll take 738.1 times 1.065 raised to the 30. This turns out to equal 4,882.063,665 or 4,882.064 billion dollars. Now, second question, can we be sure this estimate is accurate? Then the answer there is no. It's not to 1920. It's not 2020 yet. And there are several other factors that could make a difference in that cost. One of them being the Affordable Care Act.